Okay, in this video we're going to introduce you to some important concepts involving random variables. Okay, so random variable is simply the result of an experiment. So an experiment is a situation where the outcome is uncertain. Like you draw 5 cards from a deck of cards, you don't know what you're going to get. You throw a die, you don't know what you're going to get, a 1 through 6. You look at the Dow Jones index in a year, you don't know what you're going to get. And so a random variable is defined on based on the outcome of an experiment. Sorry. And basically we've got 2 types of random variables. We've got discrete random variables. Basically, for our purposes, a discrete random variable is one that can assume a finite number of values, usually a small number. For example, the dots showing on a die. It's going to be a 1 through 6. Okay, number of aces in a 5-card poker hand. It's going to be 0, 1, 2, 3, 4, 5. Number of competitors for your product. Maybe it's 0, 1, or 2. Number of free throws. Dwight Howard misses in a game. Maybe it's going to be 0 through, I don't know, 20. Let's hope not. Okay. Now, continuous random variable can assume very many or an infinite number of outcomes. In general, when there's a lot of possible outcomes, we just assume it's an infinite number. For example, an adult height. I mean, if you look at the fraction of an inch, it could be anywhere, I don't know, 3 feet to 8 feet tall. I mean, any number in that range may be possible. I don't know the shortest or tallest person in the world. Okay. The market share for a new product. That can be anywhere from 0% to 100%. Any number on that spectrum is possible. The value of the Dow Jones index in a year. The return on the Dow Jones in the next year. Okay, the worst it can go from minus 100%, it goes to 0, let's hope not. I don't know, to realistically maybe 50%. The cost of developing a new product. Say a new drug for Alzheimer's. Okay, maybe it can be anywhere from $1 billion to $5 billion, depending on how things go. Okay, so what we want to talk about in the next few videos is how to estimate probabilities for various random variables that occur a lot in the world. So if you ever took a stat class, you know there were tables in your stat book. There were the Z tables, you probably remember those for the normal random variable. There were tables for the binomial random variable and perhaps other random variables, tables in your stat book. Excel has a function, has functions basically, to replace the tables in your stat book. And we want to learn how those functions work. But before we go on to looking at some specific Excel functions, let's define the expected value or mean of a random variable, and then the variance and standard deviation. So we'll work with the discrete random variable. And for a discrete random variable, basically, the expected value is you weight each possible value by its probability. It's sort of on the average what will happen. So let's suppose we toss a dice. What's the average number of dots that show up? Throw one die. And a 1 through 6 is equally likely. So what's the average or expected number of dots to show up? Well, let's look at the possible values. We can get a 1 through 6. And the probabilities are 1/6 for each one. And probabilities have to add to 1. Now, to get the expected number of dots, you just take 1/6 times 1 plus 1/6 times 2 plus 1/6 times 3, and we can do that with sum of product, which we've learned about a couple of earlier videos, and we'll use a lot more when we talk about Excel solver. So you take these values weighted by these probabilities. Okay, and you get 3.5. So that you'll never get 3.5 dots when you toss a die. But what this means is if you throw a die a lot of times, you'll average about 3.5 dots. For example, if you tossed a die 100 times and added up the total dots, on the average you'd get 100 times 3.5 or 350 dots showing up total. Okay, now how do we do the variance of a random variable? Okay, so the variance of a random variable is the average squared deviation from the mean. For expected value. And then the standard deviation is the square root of the variance. Okay, so what's the standard deviation of the number of dots showing up? Well, we need to figure out the squared deviation from the mean and just take the expected value of that. Squared deviation from mean. Let's wrap the text. So we would take the actual number of dots minus the mean, and we'd square that. We square the because we don't want positives and negatives to cancel out. And then we weight each of those squared deviations by the probability of its occurrence. So we would do sum product these probabilities with these squared deviations. And then the standard deviation is the square root. .71. And as with data sets, it usually is the case that a random variable is within 2 standard deviations of its expected value 95% of the time. Okay, in the next video we'll start a discussion of specific random variables with an important discrete random variable, the binomial random variable. So we'll see you then.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here. and you can sort of see 4.5, or his newest book, his Analytic Stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.